Welcome to another GCSTUDIO for VS Code using GCBASIC. I'm going to take you through using legacy chips to show you how it works. I'm going to go out to a secondary machine. I'm connected in here. So I'm just going to start up GCSTUDIO and I'm just going to select my project, which I've already defined. There's no trickery going on here. This has the files I need. So let me go out to Deskcam so that you can see what's going on. I've disconnected the PIC kit 4. Now my camera is upside down for some reason, don't know why. I've got a PIC kit 2, which is this is our version of it, PIC kit Plus. You can buy this. It's connected through to a legacy chip, an 886 here with an LED, and we're just going to flash that. We're going to see that running in the GC code debugger, and then we're going to program it. Okay. So let's go out to some code and see what's going on. Here is GC code. I have already changed the chip here, and I've told it it's running at 8 megahertz. Don't really need to tell it that because it will do it automatically. And I am going to flash an LED on port C.1 for 1 nanosecond. Now, why am I doing it for 1 nanosecond? I'll tell you why. Because I just want to walk it in the I'll walk it in the debugger, then we'll change that when we go to program it. So let's just make sure that that compiles. So I'm going to press function key F6 or make the hexadecimal files, and it just quickly compiles it. It says GCBASIC, this is the build number, and it's patched it. Now, it's patched it because it's always patched it. This is nothing new. It's been patching this because to make sure that the configuration is absolutely spot on. Okay, so that took, well, that take a couple of seconds to compile. I've actually turned on some more debug here. I don't know why I've done that, but I did. Okay, so let's just get rid of that for you. Put it down there. So I'm going to debug this code. To debug, there's a little icon here on the left called Run and Debug. If I shut that down, give you a bit more real estate. Run and Debug or Shift F5, Shift Control D, it says there. Let's see if that works. No, it doesn't work. Yeah, it doesn't work. That opened up a second window. Maybe I did it wrong. There might be some Control Shift D. Oh, it does. It does work. It opens up the debugger. There we go. I just learned that. And I got this little green triangle. Because I'm zoomed out, I will zoom out. I get different real estate look as I'm zooming in and out. Debug the project. If I put it just there. So this is a legacy chip, and we're going to run the debugger. And this is the basic. This is like the level 1 that we're going to provide. And so you'll be able to do what I'm doing here with a PIC kit 2, PIC kit 3, or any other programmer you pick. But the question is, will it work with a PIC kit 2? The answer is yes. I'm in the debugger now because on the bottom right-hand corner it says stop on entry, function key F5. I am in the code. I have got a watch statement over here with port C. No, that's interesting. No lat-C on this chip because it's a legacy chip. So I'm just walking the code. And here we go. It says bank cell set port 1, port C.1. So function key F11, and it sets it over here. We saw it change on flashed over here. It went from something to 2, and then because I've got it as microseconds, we're going to be able to walk this code quite quickly. And then the next one, it says go back and do the loop, set it, and then it says clear it, and it will go to 0. Look. So we're walking the code, and this is legacy code. Let me just show you how legacy this is. This is a 16F886. We'll fancy that because that's what we compiled. And I compiled that today on the 26th of January 2026. So it's live. And there is all the code that goes along with it. It works. You can see the hardware registers. You can see the variables exactly as we did previously. Okay, so let's have a look at that variable there. That's a word variable. You don't need to expand it because our compiler, a debugger, shows you the correct construct of the variables. Hardware, CPU registers, they're very different from the advanced chips. But that's the way, because that's why we're going to have different levels of capability to be shown you. So I've got this watch, so let me just stop this. back to my source code. I'm just going to change that to 1 second because I'm actually going to program this now. Function key F5, bring up the, now does the webcam, the desk cam works when I'm, here's the desk cam. It's just programming it with the PIC Plus programmer, which is equivalent to a PIC 2, and one LED is flashing every 1 second. If you don't believe me, we'll go back into the source code. We'll change this to 100 milliseconds. And you can see in the source code these changes. So if I just compile it, we'll look in the source code. It's just compiling it, recompiled it, and now it says here, wait for a particular time. Here you go, pulse out 100 milli. Let's look at the wait command. Wait 100 milliseconds. It loads 100 into a variable, and then it calls a delay function. So it's definitely going to be different. Now, what is different about previous releases of the GC code, I should mention at this point, if I try to program it whilst I'm inside of it's not a GCBASIC source, it's actually a .s source, it's the assembly source. It will still compile it. It's got the intelligence now to actually recompile any source that it's looking at relative to the project because we're in a project folder. Here we go. The LED is now flashing. So hopefully it's really demonstrated that you can have all the same capabilities in GC code that you have with more modern chips. Make it very clear that we will have a version of the basic capability that you can just download. But the more advanced you get, we need to get some revenue from this because this has been 2 years in the making, and we need to cover our costs. We have a lot of costs involved. But that's what I wanted to show you. Minimize that. So that was GCSTUDIO for VC Code, showing you the debugger in GCBASIC for legacy chips. Enjoy.